Good day, Chidlins. This is the second part in a four-part series on accuracy, precision, and significant figures. In the first video, we looked at the difference between accuracy and precision, and now that we sort of understand that difference, we're going to look at how we express the amount of precision that we have, say, in a data set from a lab, using an agreed-upon series of rules that we call significant figures, or sig figs for short. And if you're in one of my integrated classes, I've been referring to this as topic 3B. So we'll skip over what we did before and start out with a thought experiment. So consider this auditorium. If you were standing in front of this crowd and you were asked, how many people do you think are in this auditorium? So I just need you to take a quick estimate. My quick estimate is I think that there's about 200 people. Now, how I arrived at that, didn't count everybody's heads. I can't see everybody. These people in the back are really too hard for me to see. There might be some people hiding behind people over here that I couldn't count. So there's no way for me to take an exact count. All I can do is estimate. And to make my quick estimate, I took this row that I could see most of it, counted the number of people in that row, and then multiplied it by the number of rows that there are. Still, not every seat's taken, so this is an estimate, and that's about as good as I can get. So now let's say, having just made my estimate of 200 people, that 4 more people walk past me and have a seat. Do you think that I could say with confidence that there are now 204 people in this auditorium? I hope you agree with me that I can't. And that is because the number of people that walked in, 4, is squat compared to the uncertainty in my initial estimate of 200 people. If you put a crowd of exactly 200 people and a crowd of 204 people in front of me, I don't think that visually I could tell the difference of 4 extra people in a crowd of 200. So as far as my ability to estimate is concerned, this is still a 200-person crowd because my uncertainty in my estimate is a lot bigger than 4. Now let's imagine, instead of 4 more people walking in, what if I'm told, having made my estimate of 200 people, that there's a bus that contains exactly 74 more people that are about to arrive? Can I now say 274? I hope you still agree with me that I can't say 274. Because again, I'm pretty uncertain about the end of this number. You know, that could have been 205 people, could have been 196. So I can't say 274 people exactly. I probably can tell the difference, though, after 74 more people come into this auditorium. So I think that I might be able to say that now that there's about 300 people in here, because a crowd of 200 and a crowd of 274, I'm going to visually be able to tell the difference between them, but I'm not going to be able to say 274 exactly. I'm probably just going to round that up and say that's about 300. All right, one last part to our thought experiment. Now let's say instead of estimating that I stood by the door, took tickets, and found that there were exactly 200 people. Then I see 4 more people walk in. At this point, I am safe in saying that that crowd has 204 people. So the difference here is my uncertainty is I don't have any uncertainty. I counted exactly 200 people. So when I count exactly 4 more in, I can say 204. So we need a way to kind of communicate how much error there is, how much uncertainty there is in our measurements. So when we report something, we can tell the difference between, is this a rough estimate of 200 people, or this is I laboriously hand counted 200 people exactly. Because if you go through all that effort in a lab, or in counting tickets, you want to be able to reflect your extra effort because that extra effort has awarded you with a higher degree of precision. So we're going to use a set of rules, and I'm going to get to kind of a flow chart for that on the next slide. Okay, so when we're looking at a measurement, the first thing that I want you to ask is this number defined or counted? And what I mean by that is we're going to be dealing mostly with things that can't have fractions. But if you're talking about people, you can have an exact count of people. We don't have any fractional people. Or we could have something, for instance, how many inches are there in a foot? There's 12. Is it 12 point something inches in a foot? No, it is exactly 12 by definition. So that's what I'm meaning by that. And if it's a situation where it's countable objects that come as wholes, or it's a definition, 12 inches in a foot, then you go over here and we would say that has unlimited precision because it doesn't get any more precise than 12 inches in a foot. Okay, now, on the other hand, most of the data that we're going to be dealing with is no, it's not counted and defined. We can have, fractions. We could be dealing with something like 2.5 grams. So most of the time you're going to be going over here. You then need to ask yourself, is there a decimal? Okay, if there is not a decimal, are there placeholders at the end? And what I mean by placeholder zeros is like in our example of 200. These would be placeholder zeros. If there are placeholders at the end, all the digits except the placeholder zeros are significant. If there are not any placeholders at the end, then you count everything. So basically, you're wanting to avoid counting placeholder zeros. So these are not significant figures. They're important because, they tell you the difference between, 2 or 20 or 200. Those are important. They're just not measured values in this case. All right. Coming back over to our flow chart, is there a decimal? Yes. Are there placeholders now in front of it? So, for instance, these would be placeholders in front. If there are placeholders in the front, again, all digits except the placeholders are significant. If there are not, just like before, all the digits are significant. So what you need to notice here is we're counting everything except zeros some of the time when they're placeholders. And where we're looking for the placeholders is different whether we have a decimal. If there's not a decimal, you'll be looking for placeholders at the end of the number. If there is a decimal, you will be looking for placeholders at the beginning of the number. Everything else is going to be significant except situations like this. And so let's get to some examples to make this a little more clear. Okay, let's work through some examples, and I took the little flow chart from the previous slide there so that we can refer to it. This first question, is the number defined or counted? We're going to go ahead and get this question kind of out of the way because most of your things are not going to be answered yes to that. The way that you will spot that is I will have a unit there that will be something obvious that doesn't come in fractions. People, cats, cars, things that come as whole units. Anything else, or things that have units like grams, pounds, milliliters that obviously you can have parts of, that's not going to be one of the things that we're going to consider countable. But if it's one of these things that, clearly use your common sense, comes as whole units, then that's going to be unlimited. Everything else, we're going to assume that these are measurements. I could attach units to these. Like I said, they would be units that you can have decimal amounts of. So let's run through this. This first one, 134, we're going to say no. Everything else we're going to consider as no, so we'll be starting here. Is there a decimal in 134? No. Are there placeholders at the end? There are no zeros, so clearly there are no placeholder zeros. So that sends me here. All digits are significant. I have 3 digits, so this is 3 sig figs. Okay. 21.288. Is there a decimal? Yes. Are there placeholders in front? There are no zeros, so there are no placeholders. So all digits are significant. So there are 5 sig figs in that one. Okay. 50.7. Is there a decimal? Yes. Are there placeholder zeros in front? I have a 0, but this is not a placeholder 0 because it is not on the front of the number. So when I say front here, I'm not referencing where the 0 is at in terms of the decimal. I'm talking about zeros that would be in the front of the number. So no, there is not any placeholder zeros. So again, all digits are significant. 3 sig figs. Okay. 250.00. Is there a decimal? Yes. Are there placeholders in front? There are zeros, but these are not placeholders because if there's a decimal, we're looking for zeros in the front of the number. So again, no. All digits are significant. So that is 5 significant figures. Now, you might ask, why should I be writing 250.00? Why don't I write just 250? This is the whole point of significant figures, is that you are communicating that I took the painstaking effort to measure this value all the way out to the hundredths place. And so it just happened to be 250.00, but I'm confident that it's 250.00 all the way out there. So that's why we would report this and not just report it as 250, because that's the whole point of significant figures, is to express how precisely you know that value. Okay. Tricky one on this one. Is there a decimal? Yes. It happens to be right there. Nothing after it, but we're putting that decimal right there in this case. Is there any placeholder zeros in front? Again, no. All figures are significant. So if this value was recorded, the reason for putting that decimal on there is to communicate this isn't an estimate of, oh, it's about 1,000. This is 1,000, and I'm confident that it's 1,000 down to the ones place. Don't know anything about the tens place, so I'm not putting anything after the decimal, but the decimal is there to communicate that these zeros are significant. Okay, already covered this one. 0.000475. Is there a decimal? Yes. Are there placeholder zeros in front? Yes. Okay, these are placeholder zeros. A lot of students confuse this and say, well, these zeros are after the decimal. Again, when I'm talking about placeholder zeros in front, I'm talking about zeros in the front of the number. All 4 of these zeros are in the front of the number, so we're not going to count those. The only thing in this one that counts as significant figures are the 4, the 7, and the 5. 1,500. Is there a decimal place? No. Are there placeholder zeros at the end? Yes. So when there's no decimal, we're looking for any zeros that come at the end of the number. And so we count all the digits except the placeholder zeros. So this one is 2 sig figs. 0.0105. Is there a decimal? Yes. Are there placeholder zeros in front? Yes, these 2. This 0 is not in the front of the number, it's sandwiched between. So it is going to count as a significant figure. The only thing that we're not counting are those two. So this one is 3 significant figures. Lastly, 0.005050. Is there a decimal? Yes. Are there placeholder zeros in the front? Yes. Now notice I'm not asking about this guy. He's at the end of the number. I'm talking about my placeholder zeros in front. So all digits except the placeholder zeros count. So it's all 4 of those. And that is 4 significant figures. So this shows you the rules that we will be using to figure out how many significant figures are in a reported number. And again, the reason that we do this is probably the best example of why we do this. 250.00 is numerically the same as 250. You could enter it in your calculator and those zeros wouldn't matter, but your calculator doesn't care about sig figs. The purpose is when we're communicating with others, how precise is your measurement, and that's the reason that we use significant figures. So thank you. This concludes part 2.